Hello everyone, this is again your junior high school math teacher, and from this video we will just continue what we have just started with a discussion about solving an oblique triangles. Last time I discussed how to solve an oblique triangle uh, under case 1 and case number 2 given parts, okay? And from those first two cases, we found out that uh, the application or the equation or the concepts being used to solve that particular oblique triangle is the law of sines. So in this video, we will now discuss how to solve oblique triangles under case 3 and case number 4. Now the question is, can we still use the law of sines if we are now considering the three given parts under the last two cases? Let's find out. Okay, so at first, we have already found the answer to the question whether we are still going to use the law of sines. So in this particular presentation, I think under the last two cases of three given parts, we are now going to consider a different formula, and we call this the law of cosines. Okay. Now, what does this law of cosines all about? Okay. So what you see right now from this presentation is actually the derivation of the law of cosines. I think we will have a separate video for the discussions of this formula. But for now, let us focus our attention on solving the oblique triangles applying this law of cosines. Now, ano ba ang nakapaloob sa law of cosines? Okay. Okay, actually the law of cosines are those equations highlighted by color blue. Okay, it could be this equation or this one and this one. Okay, now we have three equations associated with the law of cosines. Actually, any of these equations have only one interpretation. Okay, so if we're going to interpret any of these three, the law of cosine states that in a triangle, the square of one side is equal to the sum of the squares of the other two sides minus twice the product of these two sides multiplied by the cosine of included angle. Again, the law of cosine states that the square of one side is equal to the sum of the squares of the other two sides minus twice the product of these two multiplied by the cosine of included angle. Okay. Any of these three has only one interpretation, and that is what I have just uh, state verbally. Okay. Now, again, each of these three equations have above is known as the cosine law or law of cosines. Now, this law is used to solve the last two cases of problems involving oblique triangles. Now, what we go back to the cases, particularly case number 3. Now, what are the three given parts of an oblique triangle under such case? Actually, these are the given parts: the two sides and an included angle. Now, now let us have some examples. Suppose we have this oblique triangle. Now, obviously, there are three given parts. The two sides having a length of 28 and 18, and the angle formed by these two given sides, which is the included angle, denoted by alpha, whose measure is 122 degrees. So we're going to solve this oblique triangle, meaning we need to determine the measure of its remaining parts. And what are these remaining parts? Angle B, angle C, and this included side. Okay? So, for our solution, the unknown parts of the triangle are what? Beta, which is the angle from point B, and gamma, which is the angle from point C. And side small letter A, which is the opposite side of angle alpha, having a measure of 122 degrees. Now, what formula are we going to use? Now, this is the formula. Since side small letter A is unknown, so we make use of this formula among those three formulas that I just presented from the previous slide of this presentation. So that is A squared is equal to B squared plus C squared minus 2BC times cosine of alpha. Okay? So from this formula, we just plug in the given measures. So that is B squared, which is 18 squared, plus C squared, which is 28 squared, minus 2 times BC, that is 18 times 28, cosine of 122. Okay, yun. So, that is 2 times 18 times 28, that is actually what? 1008. Then, from your scientific calculator, press the equivalent of press cosine 122, and its equivalent is actually negative 0.5299. Then 18 squared is 324 and 28 squared is 784. Now simplifying this resulting expression further, we have what? 1642 times point 1392, that is your A squared. Then from here, we get the square root of both sides. To get A, that is the square root of this value. Of course, you're going to use the scientific calculator, and approximately your A is equal to 41. Okay? Then, what's next? So we solve for the measure of angle beta, the angle from point B or vertex B. So here we use this formula. Actually, this is taken from the law of cosines being transformed to solve for cosine of beta. Okay? So that is equal to A squared plus C squared minus B squared all over 2AC. Then you substitute the value of A, B, and C. Of course, the obtained value of A is 41. You plug in here, the value of 41 here. Then C is 28, then B is 18. Then 2 times 41 times 28. Of course, you must use your scientific calculator to compute for the cosine of B, which is 0.9325. So our cosine of this value will give us what? 21 degrees. So your beta is approximately 21 degrees. And to get the measure of gamma, we use the angle sum theorem of a right triangle, which states that the sum of all the angles in a triangle is 180 degrees. Thus, alpha plus beta plus gamma is 180. Then substitute the value of alpha and beta, which is 122 and 21. Of course, taking the result of this expression, and you will get the measure of angle alpha, which is 37 degrees. Okay? Next, for our next presentation, two sides and an included angle are given. Still under case number 3. Example, two airplanes cross each other at an angle of 49 degrees. At a certain instant, airplane A is 32 miles from the crossing, while airplane B is 76 miles from the crossing. What is the distance, denoted by small letter d, between them at this instant? Okay, so we need to illustrate the problem. Now, these are the planes. Okay? So they cross each other at an angle of 49 degrees. At a certain instant, airplane A is 32 miles from the crossing. So this is the crossing point. While airplane B is 76 miles from the crossing. So from the problem, at that point, what is the distance between these two? So basically, the problem illustrates an oblique triangle, wherein one side, the broken side, denoted by small letter d, is the distance of the two planes at that point, at that instant. Okay? So using the cosine law, we have what? D squared is equal to what? The sum of the squares of the other two sides. So that is 32 squared plus 76 squared minus 2 times these two sides, then cosine of the included angle 49. Okay, you could use the scientific calculator here. So 32 squared is 1024, 76 squared is 5700. 76 minus 2 times the product of these two, then cosine of 49 taken from your scientific calculator. And then, okay, follow the MDAS rule in order to simplify this expression. And at this point, we have 3,608.73, which is your d squared. Now, taking the distance, you get the square root of this, and approximately the distance between the two airplanes is 60, or that is 60 miles. Okay? Next. Case number 4. So the given parts are the three sides, meaning the remaining unknown parts are all angles. So example, again, we have an oblique triangles. So all angles are unknown, but all those sides are known. Okay. Side small letter A is 18. Side small letter B is 25. And side small letter C is 12. Now, to compute for the angles, we use the cosine law, which is transformed solving for the cosine of each included angle. Okay, so cosine alpha is b squared plus c squared minus a squared all over 2bc. So you just plug in the given sides from that formula, and then you simplify this expression on the left side, and we have 89 over 120. So that is your cosine of alpha. So alpha is what? Arc cosine of 89 over 120. So using your scientific calculator, alpha is approximately 42 degrees. So that is for alpha. Now, I think what we need to find out is the measure of beta. And this is the formula. Okay. A squared plus c squared minus b squared all over 2ac. Substitute the lengths of the three sides. We have this resulting expression. So you simplify that, the value is what? 157 over 432. Actually, it's negative 157 over 432. So that is your cosine beta. Therefore, your beta is the arc cosine of this negative fraction. Using your scientific calculator, beta is approximately 111 degrees. Okay? Then for gamma, we could use the formula, or you may now use the angle sum theorem, which states that all interior angles in a triangle have a sum of 180 degrees. So substitute the value of A, B, and C. So this is the resulting expression. You simplify this, we have what? 161 over 180. So that is your cosine gamma. And therefore, gamma is arc cosine of 161 over 180. And gamma or angle gamma is approximately 27 degrees.